Good morning, good afternoon, good day to everyone out there, as this is DBA Fundamentals presentation for September 7th, 2021. Today's meeting is with Warner Chaves. He's presenting Intro to Data Engineering with Azure Synapse Analytics. What seems to be a great topic. I know lots of people are asking to learn things about this. I, for one, as well, want to learn more about it. In the top right-hand corner of the screen, you'll see the DBA Fundamentals Leadership Team. Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right-hand side of our names, you'll see our Twitter handles if you need to get in touch with us for any reason. Below that, you'll see our many social media links, connections. You'll see first is the meetup on DBA Fundamentals for how to get into this team as one of many things. Also, you'll see below that the dbafund.org website, where you'll find all of our upcoming presentations as well as our past presentations. Below that is our YouTube channel. We have, as I said earlier, we have all of our past presentations on there. If you'll be so nice as to subscribe to our channel, you'll see that we have, whenever a new presentation is uploaded, you'll actually get the link to start with right then and there to know when it's available for you. Also below that is the Twitter. You'll meet us at DBA Fun. And below that is our Slack channel and our LinkedIn group as well, where you can reach us at any time to ask any questions you may have, or just want to know anything about DBA fundamentals. Also, reach out to us in via one of those means, so that if you have a presentation you'd like to give the group, please reach out to us on any of our social media accounts to let us know, and we'll try to set you up as well. Speaking of that, all of our sessions are recorded and are usually available within 1 to 2 days, where they'll be available on our YouTube channel. And with that, we go to Warner. And here's his bio. I'm sure he'll give a much better bio as well on that one. So with that, we send it over to Warner.
Let's do it.
And if everyone can remember to turn off to mute yourself as well.
Yes, I think you need to mute everybody there, Kevin. All right, awesome. Well, thanks everybody. Let me get my screen sharing going, and we'll get started. All right, sharing. And Kevin, if you can let me know when you can see my slide deck.
I see it.
All right, so everybody, thank you so much for joining me. I mean, if you're in North America, this is probably like kind of like a lunch and learn for you, or if you're in the West Coast, it's like a breakfast and learn. If you're anywhere else in the world, I appreciate that you are here today to just share an hour of learning with me. This is Intro to Data Engineering with Azure Synapse Analytics. Allow me to introduce myself. My name is Warren Chaves. Been a DBA consultant for 15 years. I used to do DBA work at Hewlett-Packard in Costa Rica. I've been a Pythian for a long time now, and I'm a solutions architect. I'm honored to be a Microsoft Data Platform MVP. Feel free to reach out to me on Twitter at warchav. Check out my personal website, createdatapros.com. And if you think of something else later on today that you didn't get a chance to ask, feel free to shoot me an email, warner@createdatapros.com. Also, feel free to add me on LinkedIn. If you just search me by name, I am there, and I love to connect with all the people that are always here attending these sessions and learning together. And I usually post a lot of material on my LinkedIn as well. All right. So the agenda, basically, I'm going to discuss data engineering first. What is data engineering? What is it that is coming in the market? And obviously how Synapse Analytics helps. It's a beginner session. So if you are a seasoned data engineer, then you're likely not going to learn much unless you haven't had any exposure to the Synapse environment itself. Then you'll see a little bit of Synapse. But otherwise, I'm assuming that you are a DBA or somebody that is in the data field and you're not completely into data engineering yet, or you're not familiar with Synapse Analytics and what it is, okay? So I'm gonna go over data engineering. I'm gonna go over a little bit of Synapse, very, very basic stuff, and then just demos for most of the session, because in something like this, I find, especially when we're dealing with a beginner topic, to just go straight into demos, show people, give us some examples of the stuff that you can do, and we learn quicker that way, and hopefully motivate you, pick your curiosity, think about if you would like to learn a little bit more about data engineering, and fire up an Azure account and a Synapse environment and learn. All right. So prerequisites, and not just prerequisites for this session, but I think basic prerequisites for somebody to tackle a data engineering project is, well, in the case, if you're going to use Synapse, then obviously you need to know Azure basic stuff, but the Synapse portal is very user-friendly, so we'll go through that anyway in the session as I show it. You know databases and you know SQL. That's pretty much the main thing that you need to know to get started. Obviously, if you're doing data engineering, most of it you'll be dealing with the most familiar concepts, tables, columns, fields, etc. If you're working with semi-structured data, something like JSON, for example, usually you might be doing some computation on the JSON, some extraction, but at the end of the day, most people end up extracting what they want into some sort of tabular structure and then working with that, right? Um, if you know basic coding, that definitely helps, especially as you go deeper into the data engineering part. You might need to do some scripting, some transformations that require a little bit more expressiveness than what you can get out of SQL, right? But nothing exotic, you know, basic stuff of coding, variables, parameters, functions, loops. You can express almost everything with those. If you know a little bit of object-oriented programming, that also helps, especially with languages like Python or C# that are more object oriented, right? All right, so data engineering. What is data engineering? What is it not? This is a topic. Um, a few years ago, this role, I don't think it was really well understood or specified, but nowadays there are hundreds of thousands of openings on LinkedIn if you go and check for data engineering all around the world. It's definitely a role that is being better understood and that is booming in the marketplace right now. And I think is a great field for DBAs and data professionals in general to look into, right? So data engineering is the process of preparing data to be consumed. Be consumed could be by an upstream system or a person, right? So it doesn't have to be a human being. It could be maybe you are preparing some data to be consumed by an API, for example, right? So that could be a system itself. It's not that you're preparing it for a person. It could be that you're preparing it for another system that's going to consume it. So data engineering tasks, what are some of the things that data engineers do? All right, so integrating sources, either by doing some data modeling to integrate different sources of the same data into one data model, or augmenting a data model with data from different sources, or also by doing it physically, right? If you are working on scripting and transforming data directly into a data warehouse, for example, then you will be physically integrating them by storing the data, creating the tables, putting them together, right? Cleaning up data is a huge data engineering burden. Most of the data sources that you'll deal with will have some sort of data integrity issues, believe it or not. Um, I haven't had a project yet where there wasn't something that had to be done to the data, even though you would think like most OLTP systems will come in with full referential integrity and all the foreign keys and everything, so everything would be nice and clean. You run into things all the time, right? For example, addresses that are not correct, or names that are missing parts, or the same thing, like the same type of entities expressed in 2 or 3 different ways, and so on, right? So there's usually some cleanup of data required. Transforming data is usually required as well. Maybe if you're taking data from an OLTP type of schema into more of an OLAP analytic schema, you'll have to transform that data. Transforming formats, right? And maybe you have a partner that sends you some data in CSV files and you are saving it in Parquet now so that it's a more efficient format that you have in a data lake. You have to do that as well. And of course, you have to make sure that it performs well, right? I'm getting some noise on the background there, so if everybody can mute themselves, looks like somebody's just opening drawers and stuff. So thank you. All right. Making sure it performs well, right? So it's not just to deliver a solution. If the solution is not really usable by anybody, then nobody's going to use it, right? So you got to make sure that the upstream services or people that want to use your data engineering solution, your data model, etc., they can actually work with it and get decent performance. Now, this one, last one, a lot of people tell me like, well, isn't that like a DBA task really? But I mean, it's a shared responsibility. And as these solutions like Synapse grow and become more and more popular, there's going to be less demand for pure DBA people. It's going to be a mix of roles anyway. This is an image that I got from Twitter. I don't know who the original author is. I just thought it was pretty funny and kind of illustrates the point pretty well, right? So uncurated raw data is the nonstop train. Data scientist is the child just playing with the ball, and the data engineer is Superman trying to, protect that data scientist from all that uncurated raw data, right? So in this case, data scientist is the upstream consumer, and like I said before, data engineers, they'll have to grab the data sources, massage them, and clean them, create a proper data model, collaborate with the data scientists and figure out what they need and help them build that data solution, right? So the main process of data engineering, how it kind of interacts with Synapse as well, right? You have to help identify sources, help bring them into Synapse themselves, explore and understand that data, different file formats that it comes in, be able to integrate it, clean it, transform it based on your requirements. You should verify that it can be consumed, right? So that means you have to help people connect to the data, figure out if they have the right permissions, figure out that it's a format that they can read, that it's using the data types that they wanted for it, et cetera, right? So you have to assist the consumers as well in a way, right? You build something, it's not just you build it and you forget about it. You have to document, you have to do some knowledge transfer, show people how everything works, et cetera, okay? And when you're doing all these things, you also at the same time, you always have to be mindful that the data is at the right granularity, right? If your finance team needs sales data at the order level and you're only providing it at the regional level, then you have a problem, right? It's not at the right granularity. Make sure that it has all the necessary fields, right? If they're trying to analyze discounts and you don't have the amount discounted per order, then obviously you're not going to be helping them much. You have to make sure that the data is correct, most importantly, right? And that it is timely, right? So if they need daily extracts and right now you're only providing weekly, then you need to go back to IT to work with the application team or whoever it is that you might need to talk to make sure that they get their daily extract, right? So correct and timely, very important, right? Now, this is a very common question I get nowadays. It is basically, so this a lot sounds to me a lot like an ETL developer. I'm an ETL developer. Should I just change my resume to say data engineer? The answer is probably yes anyway, but it's not exactly the same thing in my opinion and based on what I see in the market and what our clients come looking for. So biggest difference is that a data engineer should not be boxed in a specific ETL tool, right? So don't call yourself a SQL Server Integration Services developer or an Azure Data Factory developer. Just call yourself data engineer. Um, a data engineer should be familiar with relational database systems. That's always been the case with ETL developers for many years. But the biggest difference right now is that data engineers are also expected to be familiar with SQL engines that are distributed, MPP, massively parallel, such as Synapse, such as Google BigQuery, such as AWS Redshift, such as Snowflake, Spark, etc. Right? So when I say big data there as well, there's an expectation nowadays that a data engineer will know how to work with Spark. Data engineers should be able to code, not just write SQL, as I mentioned on the prerequisites. And it should be, in my opinion, because it is an engineer role, it should be opinionated, meaning that, data engineers should have an opinion on how we should structure the data, how we should structure the warehouse, how we should structure the data lake, and be able to make that into a reality, right? So it's not just somebody that is told what to do, but it's also somebody that can figure out what needs to be done, all right? So in my opinion, every data engineer should be able to do ETL development work, but not necessarily every ETL developer is a data engineer, all right? So important to select the right tools if you're starting a data engineering project or you're advising your organization on starting a data engineering project. The data engineering process is a mix of different tools, right? There's some tools to move data around, to bring data in. There's storage necessary if you're building a data lake or if you're just working with an MPP SQL engine. There's going to be different types of storage that are involved in it. There's going to be processing, so different ways of doing compute, right? And there's going to be outside exposure, right? How do we share the data or we expose the data to the outside world after we're done with it? So this is where Synapse comes in. This is where Microsoft has seen a market opportunity and developed the Synapse service, right? So Synapse Analytics. Synapse is a cloud service that bundles an entire data platform and then entire data engineer workflow in one place. So you don't have to go in and figure out all these different pieces of a data platform and how to put them together and how to integrate them. Microsoft team has already done that, put it all together in a big bundle for you, so you don't have to do that yourself, right? So in one service, we have all these fundamental blocks, right? Already configured, integrated for you. We'll have the data lake storage as the basic service underneath, right? So on top of data lake storage, we can have Spark pools, we can have SQL pools. The SQL pools are also subdivided into dedicated pools and serverless pools. And then if you need to bring data in and push data out, we have Synapse pipelines, which is basically a different version of the Azure Data Factory engine. If you never use ADF, I'm going to show you a little demo as we go along, going through the portal. And inside Azure Data Factory, we also have different ways of transforming data now too, because Microsoft has developed what they call data flows. So the data flows are a transformation engine inside Azure Data Factory or Synapse pipelines, which is the same thing. Then there's another thing there. You see it says pipeline/link because Microsoft is developing what they call Synapse links. Right now it works only with Cosmos DB, and it is the capability of querying through Synapse data that is sitting in a separate service. So right now there's a Synapse link for Cosmos DB. So if you have data in Cosmos DB, you can query it from Synapse without having to copy the data around. So that's pretty cool. And then the last corner, top right, you'll see Power BI. That's just an example to put in, like, there is visualization integration with Power BI, obviously, because Microsoft, makes Power BI and they make Azure. But Synapse is not limited to Power BI. You can hook up any of the major third-party visualization tools just fine to the Synapse compute engines, be it the SQL pools, and it will work. It will think it's just talking to a regular SQL database. So, if you work with Excel, you can connect it. You work with Tableau, you work with Click, Looker, um, any other big visualization tool, then it's going to work regardless. Okay. All right, let's jump into the environment and get a better feel of how it works. All right, so oh, wrong window. Sorry. There we go. Azure Synapse. So this is Synapse. If you never use Synapse, let me just zoom in a little bit. All right. Okay, so this is a fully expanded Synapse experience. There's the home here. It just has your workspace and it has the recent resources that you've used. And then there's these different tabs here on the side. So there's data. If you want to explore data, it has this explorer here. Then there's develop. Develop, you see all the different artifacts that you have in your Synapse environment: Power Query, SQL Script, Notebook, Data Flows, or Power BI. I have an example of all the ones that we'll use for data engineering. We'll just go through them as we work through the session. Integrate is the pipelines. This is the piece that is similar to Azure Data Factory. It's basically the same engine as Azure Data Factory, but inserted into Synapse and integrated with Synapse. Then there's also monitoring that allows you to look at what's happening inside your workspace. So if you create jobs, if you create pipelines, you can monitor all those things inside your Synapse environment. And the manage is where you basically configure all the different resources and other settings and configs of your Synapse environment. Okay. If you look here at the very top, you'll see here it says main branch. So Synapse also supports integration with GitHub so that you have everything source controlled. If you do a change to a script, you can commit it and it goes straight into source control, and you can develop your own DevOps or data ops processes using the GitHub integration, right? So you can create multiple branches. You'll see here. Right now, I don't have a branch. I'm just working off the main branch because I'm not doing any development work on this. This is my demo environment, obviously. But you could create a new branch, make a new feature branch, for example, develop some new stuff on your data, and then when the code is ready, just promote it to the main branch if you want. Okay. And there's a template if you want to work with Azure DevOps. There are some templates made for basically promoting different branches to a new main branch, right? So to basically move from development work into production work. And I haven't used it yet, but I know that Microsoft created some templates on Azure DevOps to do that kind of stuff too. Okay. All right, so first let's look at the SQL pool. So that's the number one thing that most people will be working on when they're dealing with Synapse. There's different types of SQL pools. So you'll see here, I got a couple. One says serverless and the other one says dedicated, right? So this SQL DW is one that I created and it's dedicated. This one just says built-in is the serverless. So the difference here is that the dedicated pool is a cluster of machines, right? And when you turn this one on, you're consuming resources, right? And if you're not querying it, it's still consuming resources while it's up and running. Serverless, on the other hand, you pay by queries. So you write one query, two queries, three queries. You run the queries, and the amount of data that you consume, like how many bytes you end up reading, it's what you get charged, right? And if you read up to 1 TB, I think it's $5 per terabyte or something like that. And if you're not doing anything, so you're not running any queries or anything, then serverless is not billing you at all, right? So that's the two main SQL engines that you have, serverless and SQL DW. So if you see serverless, I can control the cost of serverless. You can put in, I don't want to read more than X amount of data, so I know that I don't have to pay more than something. But other than that, you can't do anything to it, right? You can't have serverless be faster or add cores to serverless or anything like this for now. You see here the size, it just says automatic and that's it, right? If you're familiar with Azure SQL Data Warehouse, then the dedicated pool is basically the new version of Azure SQL Data Warehouse, right? So you do have to pick a size, you have to start it up, and so on, right? So let me see if you go to new, for example, I could create a new SQL pool, and you see here where I have to actually select the sizes for it, right? Because it's a resource that it's dedicated. So when I start it, I start paying for it. If I pause it, then I don't pay for it, but I still pay for the storage, right? And you can go all the way to the cheapest, which is the one that I run for my demos, of course. And this you can see mine is in Canadian dollars because I'm up here in Canada. But so the starting cost per hour is probably, if you look at this in US, it's something like 1.3 or something like that US, right? So if you're just looking for learning, you're just gonna dedicate, 1 day of learning on the SQL pool, then it's not too bad. It's not gonna break the bank, right? You're gonna pay like $10 or so for a full day of learning. Just make sure that you pause it at the end. This is enough for just learning, right? If you wanted to do a real production workload, you're gonna go all the way, jack it up to the top max. Well, you can see the max here actually says if you want to create a pool with the max, you got to call support because at that point they're gonna charge 600, well, almost 600 Canadian per hour, so about 500 US per hour, and they want to make sure that people know what they're doing, right? But it looks like without support, you can go all the way to DW 5,000. That would be about $100 per hour, right? But anyway, the point there to be is that the actual dedicated pool, you do have to size it and you do have to um, start it up and turn it off, right? I'm going to show you a script here with the dedicated pool. And let me collapse all this to get some screen real estate back. I can zoom in a little bit more. All right, I think that's good. So the dedicated pool, there's nothing special about it, right? There's nothing exotic. It is just a slightly different flavor of SQL than SQL Server. So it's not exactly the same as SQL Server, but it is very, very, very similar. So the first thing is that when you create a SQL pool, it gets assigned the database, okay? So unlike SQL Server, where you create an instance and then you create a bunch of databases in an instance, the pool right now comes um, attached to one database, but you can create multiple schemas, right? So you can create a bunch of different schemas inside the database. So you can still do some multi-tenancy if you wanted to, you just have to separate it by schemas instead of creating a bunch of different pools. I would recommend just create one pool and then create multiple schemas, right? Um, so here you can see I create a schema called music service. Then you can see here general create table command in the SQL dedicated pool. And the biggest difference in the in the create table for the SQL dedicated pools is this distribution equals something, right? In this case, it says round robin. So what's happening there is that behind the scenes, the SQL dedicated pools are a distributed system, right? So you'll get a bunch of, let's say you create, a SQL dedicated pool that has like 3 nodes, right? So this will be node 1, node 2, node 3, and you want to distribute the data around robin, right? So the idea is that multiple machines can access different amounts of data. And the way this works behind the scenes is that you'll get a database 1 all the way to 60 databases. This is how it works internally for the dedicated pool, right? So if I have 3 nodes, then this node will grab databases 1 to 20, then this one will grab from 21 to 40, right? And then last node will grab databases 41 to 60. And if I specify distribution round robin, then this user details table, what's going to do is that, let's say it has rows 1 to n, is going to go, okay, row 1, you go to database 1. Row 2, you go to database 2. Row 3, you go to database 3, and so on, right? So this is the biggest difference and probably the most critical difference between the SQL dedicated pool and the MPP engine than the regular SQL server that people are used to working with, right? Is that you have to specify a distribution. And the distribution could be round robin, doing something like this, or it can be a hash. So you specify a column, right? Like let's say C1, and then all the same values, as long as the column has the same value, it will go to the same database, right? So if a bunch of records have, states in the US and they have, let's say, I don't know, like Louisiana, then all the Louisiana records will go to the same place. Or if you have California, then all the California records will go to the same place, and so on, right? So this is the biggest difference in the SQL pool. The SQL pool is where you will put your enterprise warehousing data, really. That's what it's for. So it's a full-blown database engine, just like the one you're familiar with SQL Server, with some extensions like I'm showing right now. But it is the one that's probably going to perform the best. You can use column store. Once you add column store and you add on top of that the parallelism of the MPP model, then you can really work with very, very large data sets, right? Um, it makes it really easy to bring in data from your data lake. You can see here that the dedicated pool has a copy command. And the copy command, what it does is you just have to define the table and then you say, copy into this table from, and you can specify uh, right there in line the details of the files that you want to bring in, right? So in my case here, for example, in this example, you can see I am doing a copy. I am selecting CSV, right? If I want to write down any errors that might happen, you put them there. And then something else that the dedicated pool does very well is that it allows you to specify a label. So after you can go back and try to analyze each request through a label. So it makes, again, in the sense of data engineering, it makes it really easy to bring data in, just run these copy commands. And to be able to do work in parallel and maintain good performance is done very easily as well by using these distributions, right? In this case, like I said, this example is just round robin, but there's hashed. There's also duplicated. If you have small tables like a date dimension, for example, then you want to put in every single node, then you can do a replicate distribution as well, right? Something interesting that is part of most MPP systems. This is not just an issue with Synapse, by the way, but from people that are coming from the straight, regular SMP, that's very straightforward model of referential integrity, they might think this is kind of odd, right? So it says primary key, but it's not enforced, right? So what does that mean? Basically, it means exactly what it says. So you can define primary keys, or you can define foreign keys on the Synapse engine, but they're just for documentation. They're just so that they decorate your schema. And if somebody uses a tool, let's say, that generates diagrams and stuff like that, then you can see those things decorating the schema, but they're not enforced, meaning the engine is not going to verify that you are indeed inserting unique records based on your primary key field, right? And this is not just Synapse. This is all the MPP engines. Like Snowflake doesn't do it. BigQuery doesn't do it. Redshift doesn't do it. This is for a reason of performance, right? We're talking about some of these clusters can have dozens of nodes, and imagine having to search for every single primary key on all the nodes every time you want to insert a new record. It would be really, really slow, right? So that's why it's done. Usually the way to work around it is by simply doing a cleanup phase during ETL to make sure that you're not repeating any keys or something like that. Synapse does provide identities though, so if you want to use a Synapse generated identity, you can do that, but it will have some gaps, okay? So that's the main way to deal with this. This is the copy command. Let me just show you one more example. It's right here. See here, this one, we're creating the table as well, but in this case, we're using a different distribution, like I said. Now we're hashing by artist. Basically means that all the rows, this is how many times a user plays a particular artist in a music service. All the rows that belong to the same artist will go to the same database. So, all the people that are fans of, let's say, the Beatles, then they will all end up in the same database because we're hashing by the artist, right? So if we do queries that are grouping by artist or aggregating by artist, they're going to be having better performance than other fields because the data has been co-located by the artist, right? And then finally here you can check and see there's native support for Parquet as well. So if you need to specify the file type, just say it's Parquet, and then you can do the same copy command and bring the data in really easy, really fast with native support for Parquet as well. And Parquet is pretty much the de facto file format that Microsoft recommends for the data lake and for doing ETL. So if you're bringing data out and you want to store it in the data lake in some intermediate format, Parquet is a really good choice. I like Parquet too because it has data types and it has the schema saved inside the file, so you don't have to guess what the file has inside. And because it has actual data type support, it's not like a CSV where one line you can put all numbers and then the next line you can put less columns and all names, right? A CSV sometimes probably happened to everybody in this call. CSVs, people end up with like really like butchered up files that are really hard to load and stuff like that. Parquet is a lot better for that because they're more structured, right? Okay, so this is how the dedicated pools work. And this is very similar to SQL. It's not as interesting. Now, Microsoft added another engine inside the Synapse environment, which is this one, which is the serverless engine, right? So if you see here, when I say connect to the built-in engine, that means the serverless engine, right? And then to be able to read and write from the serverless engine, we use what is known as external tables. So you have to do a several sequence of steps to be able to read from the data lake storage, right, using external tables. There's two ways to read data from the data lake through the serverless engine. I'll show the external tables, and then I'll show you the other way, which is using an open row set function, which is a function that has existed in SQL Server for a very long time, but Microsoft really augmented it to do a lot of stuff with the serverless pool. So you can see here, for example, I can create external data source, and basically I'm just putting in a data lake account and a data lake container. Then I create a file format. In this case, I have some pipe delimited information, or I can create a CSV format where we have a header. So the first row is row number 2. I can specify a Parquet format. And then I can say, well, I want to create an external table. And you can see here the data source. So it's this one that I created, the location inside the data source, and the file format, right? And if that's created, then you can just go ahead and select, and everything, it just works. Here, let me just run this. DVO artist list. Oh, I guess I don't have this table created. Let me just do that real quick. Create external table. Just run it. And this is a serverless query. So if you notice, I didn't have to. I just ran the create external table, right? And I didn't have to explicitly start the service. I don't have to worry about stopping the service. Here's the data from that file, by the way. You guys can see it here. I just did a select top 10. But then the way that this on-demand serverless engine works is this particular query, it read a certain amount of data. We can look at the messages and it'll say total size of data moved is 1 megabytes, right? So all I'm gonna pay for this query is the charge for that 1 meg that I just read, right? And that's, like I said, the price rate is about $5 US dollars per terabyte read. So I have to do 1 million queries just like this one that I just did before I have to pay $5. So it's not bad, huh? This, because of this characteristics, the fact that it's on demand, the fact that you only pay per query, the fact that you're is used to interact with data lake files, then this serverless engine is more for like exploration and ad hoc analysis, right? The serverless engine, even though some people are tempted to try to do full-blown warehousing with serverless engine and then, have really low costs, in my opinion, that only works with very small data sets, like tens of gigs. If we're looking at hundreds of gigs and more, you're going to have to pay and just go into the dedicated pool, which is a little bit more expensive, obviously, but it will give you way better performance for larger data sets, right? But if you're just looking for doing ad hoc exploration analysis, then the serverless engine, in my opinion, is really, really good. In the future, what I would like to see eventually is that Microsoft basically merges both paths, right? And so if you want to do serverless, and it doesn't matter if you're working with data lake or if you're working with some of your data stored in the dedicated pool storage, you just be able to do a serverless query and that's it. And if you want dedicated compute, you'll still be able to dedicated compute, right? So that would be the ideal situation, obviously, so that you can work with both consumption models. But right now, they are separate, right? You can put data in the dedicated pool and query it with the dedicated pool, or you can put data in the data lake and query it with both, but the storage will still be just data lake files, right? All right, and then the other thing I want to show you is the other way to access data on external tables, sorry, on the serverless engine, is by the open row set command. So you see here, Microsoft has augmented the functionality of open row set, where you can pass it paths of files in data lake, and it can read that really easily. You just have to say the path and the format, and you don't even have to specify the schema, and you will get your result through the serverless engine. So you can see here, I'm just gonna run that, and boom, we get it right away, right? So if you don't want to even bother creating data sources, creating locations, creating file formats, Then you can look at just using open row set, and right away you can get to exploring and analyzing the data that might be in your data lake as files without having to create all those other artifacts, right? You just have to specify it as parameters to open row set, right? In this case, I'm just doing Parquet. You can do relative paths. You can switch collations if you want. Um, it works with CSVs as well. So you can see here, I'm doing pretty much the same thing I did before, but I'm doing it with a CSV file, and it works there as well, right? So this, again, this engine allows you to read, transform, and um, process the data, but the serverless engine only works through the data lake storage, right? It's not going to be able to work with the data that you have stored in the dedicated pool, right? The dedicated pool has its own storage, and it's more expensive because it's more like the regular SQL Server type of storage. Remember the architecture where I just mentioned, it has 60 databases under the covers to store your data in premium storage, right? It makes it a lot faster for actual large scale enterprise reporting, right? But for analysis and just querying regular stuff like this, then this is another engine inside Synapse, the serverless engine, that can work really well and can give you really good cost efficiency, right? Because you only pay per query and it's a small charge per terabyte, okay? So that's engine number 2 inside Synapse. Now, the next engine that's also inside Synapse is Spark. So if you're not familiar with Spark, you probably heard of it at least. Spark is like the de facto open source distributed big data engine that everybody uses if they're going to stay in the open source ecosystem, or they just want a quick transformation engine that they can use and not have to pay extra licensing for it. There's millions of libraries and packages that work with Spark. Spark supports multiple languages. You can see here. This is the notebook experience inside Synapse. You can have Python, Scala, C Sharp, or just SQL itself, right? And Spark, some people believe that, oh, this big data stuff is very intimidating or is really complicated. I don't know how to get into it, but really Spark is not that doesn't have such a high learning curve as most people believe, right? So you can see you create a database, and this will actually even look really familiar if you're users of T-SQL, right? You create a database, you set the database context inside a Spark notebook. Um, you create what is known as a data frame. A data frame is basically like a virtual representation of some data. So here you can see, for example, I want to do just Spark, the read, that load. Very easy to read data back and forth with Spark as well. This is Parquet files. And then you create this, what is known as a data frame. And this data frame, as I said, is basically a virtual representation in your cluster of the data that you are reading, right? And then just as how you can read the data as well, you can display it, you can process it with other Python libraries, in this case, pandas. So this is the other part where Spark also is very extensible, right? Because you have the entire availability of Python and Scala and Java and all these other languages that Spark supports so that you can augment your solutions, right? And then um, once you are ready to, you did some transformation after you read the data and whatnot, it's also really easy. You just have to say, okay, so this particular data frame, dot write, dot save, and save it as a table. So at the end of the day, Spark itself also has a catalog of databases. It also has a catalog of tables. It's nothing, as I mentioned before, nothing that is too out of the ordinary for people that are used to working with regular relational database engines. And Synapse itself is actually very handy. It comes with a catalog that integrates both, all the engines, right? So we have the dedicated pools. I can browse it and query it through the Synapse GUI. The serverless, you can see it's the serverless because the icon is a little bit different. The dedicated pool has like a house on it. The other one has like a little power on and off button. And then the ones that have the asterisk here, the star, those are Spark databases, right? So you can easily browse them and see what you have saved, whether you have tables, you have views, you can open the tables, explore the types and whatnot, right? So very easy to work with as well on Spark. And you can create, let me go back here, show you. You can create multiple Spark pools, which basically means multiple Spark clusters if you wanted to. And you can also size them to crazy sizes. So here you can see right now, what was I running right now? I'm running a small cluster, a 5-node cluster of small nodes. Small nodes are 4 vcores, 32 gigs of RAM. But I mean, you can go crazy with this, right? There's up to triple extra large nodes. So that's 80 vcores and half a terabyte of memory per node. And if you wanted to do that, let's just do it for fun. And you can go up to 200 nodes of that, right? And that will be almost 3,000 Canadian dollars per hour if you wanted to run that cluster, right? But if you do the math, I mean, it's half terabyte per node, 200 nodes. You're running a cluster with 100 terabytes of memory, right? If you have a job or a query or report that discard, that needs 100 terabytes of RAM, then you probably have the pockets to pay for the hours that it takes to run that query. It must be a super important report, hopefully, because it's going to set you back several thousands of dollars every time you run it, right? So that's the Spark engine. And then the last one I want to show you is the pipelines engine. So the pipelines engine, let me make this smaller. This is the pipelines, right? So this is very similar if you're familiar with Azure Data Factory. It's basically the same engine, right? It has a bunch of activities here. You can see Synapse activities, copy data movement activities, data flow, and then other stuff, right? You need to invoke an Azure function if you need to invoke a Databricks notebook or a job or some Python script. If you want to run some, this is from the old data lake implementation that had this thing called uSQL. If you need to do some control flow and orchestration, right, then Data Factory also provides. This is very familiar if you're familiar with SSIS, by the way, very simple. So there's lookup activities, executing a store proc, executing another pipeline, work with variables, put some weights, validate, and stuff like that, right? And also inside the ADF engine or Synapse Pipelines engine, there's also this new concept, well, not new, it's been there for a while, but a lot of people are still not using a lot of it, is the transformations inside ADF themselves, right? The data flows. There's two different types of data flows. I'm going to open this one just to show you real quick. This is just known as a data flow. When Microsoft introduced it, it was known as a mapping data flow. And the idea is that you specify, you can see here, I have two different sources, and then each step, I'm just doing one transformation to those sources, right? So you can see here where I have a SQL table as a source, and then a file as a source, and then I'm augmenting this data set by adding a column from the file. Then I'm doing a change in the data set by removing some redundant columns. And then at the very end, I just write to the data lake, right? So mapping data flows allow you to do transformations by specifying them like this step by step, setting up configurations similar to what you would do with SSIS and not having to, basically saving you that time to having to code them if you wanted to code it in something, right? Under the covers, this will translate your steps into a Spark job, and you don't have to manage the clusters or anything. You don't have to write the Spark code. You just have to create this GUI-based flow, and then you're done. The other thing that is also available, and this is the last engine, let's say, that you have for transformation and cleaning and whatnot inside Synapse, is what is known as a Power Query, right? So Power Query, if you're familiar with it, Power Query has existed for a long time. It's the engine that was inside Excel a long time ago when the Power tools were introduced, right? Power Query, Power Pivot, And that basically was the foundation for Power BI, right? And then if you've used Power BI Desktop, then this looks very familiar to you, very likely. It is pretty much the data modeling transformation view that you get from Power BI Desktop, right? The difference here is that it's been inserted into the Synapse workspace, and you can specify the sources integrated into Synapse. You can do different transformations to them, all GUI based as well. And then at the end, it works under the covers similar to the mapping data flows, where Synapse will take your Power Query and will translate it into a Spark job and will run it inside a Spark cluster. So you can do these at scale, right? So the biggest challenge sometimes, obviously, if you're working with Excel or Power BI Desktop and doing these things, is how do we operationalize them and do these transformations at scale, right? That's where Synapse comes in, when you're dealing with hundreds of gigabytes, maybe terabytes, maybe even petabyte scale compute. How do we make it scale? And still be able to support these tools that are more user-friendly, low code or even no code, such as Power Query, right? And the solution here that Microsoft has put in is to grab these tools under the covers, translate into Spark, and create Spark clusters behind the scenes to run these tools and these jobs. Okay. So that's a lot of Synapse in a low amount of time. So that's, I think this is a good spot to, let's do the recap. So data engineering in general, it's an exciting field for data pros. I feel like this is an opportunity nowadays for people. If you haven't looked into it, if you are just doing other type of data dev work or DBA or administration work, this is a good field to go into, check opportunities there and start learning. Synapse is a great product from Microsoft. To be honest, at the very beginning, when they announced that they were going to release this product that was going to integrate all these different things together, I was very skeptical of it, but it actually works pretty well. And we've been able to deploy it successfully, and clients seem to be happy with it because they like this integrated environment, right? Everything's in one place. You do everything in one place. You don't have to be switching back and forth between tools. It does have multiple ways of doing data engineering, right? The same problem could be solved with SQL pools. It could be solved with Spark. It could be solved with pipelines and data flows. It's up to the data engineer to figure out what is the tool that might work the best and what is the tool that they like the most too, right? A lot of personal preference goes into play there as well. And the best thing, especially when we're talking about a chapter like ours, the DBA fundamentals one, is that Synapse makes it really easy to just get up and running and learning and demoing things on your own, because you don't have to configure the underlying environment, right? The data lake storage, the pools, the Spark, all that is pre-configured for you. So it's very, very good environment for learning, in my opinion. And because of the more aggressive pricing that Microsoft has implemented as well, it's not something that will break the bank if you just work with it for a couple of weeks to learn on your own. Okay, and there's really good resources for learning Synapse more in depth and data engineering in general. Microsoft Learning Academy has some good stuff. Pluralsight has some really good stuff as well. And I'm sure you can find other stuff in Udemy, all these other websites as well, right? So lots of resources out there now. Okay. All right, thank you. And I wonder if we have any questions at this point or not.
No questions from the audience, but I have a couple of questions.
Yeah,
What is
sure.
the actual website for when we're actually using Synapse?
So you should create it on the portal, and then when you go on the portal, there will be a link to your workspace. Yeah, because it's web.azuresynapse.net, and then you can select the workspace that you created, right? So it's its own website that is managed by Microsoft, and then you go on it. But usually people will just, once you create it on the portal, you have a link to go into Synapse, and then you just follow that link always.
Cool.
But it is web.azuresynapse.net. Yeah.
All right.
And if you don't have any, I think it might actually give you a link to go and create one as well. Prices also something I forgot to mention, but some people might think might wonder about is the storage has also been discounted heavily. So I think nowadays it's about 20 US dollars or something like that for 1 terabyte of storage inside the Synapse workspace. So it's not bad for learning. You just you know, if you just destroy everything when you're done, you're gonna pay about $20 of storage, if you know, up to 1 terabyte for 1 month. So not bad. All right.
And from Samuel, what is the best training site in your opinion to learn these things about Azure Synapse?
Yeah, I like the Pluralsight stuff. I think the Pluralsight's pretty good. I might be biased though because I work with Pluralsight too, but I do think that there's a lot of work that goes into those. So you know the quality is usually pretty good. The Microsoft does have some good resources though as well in the Microsoft Academy as well. But what I find the biggest difference is obviously the Microsoft resources are always, you know, very positive, right? Because they're the ones that made the product, whereas some of the other stuff might be a little bit less biased and might talk a lot, you know, about workarounds or how to deal with some, you know, current deficiencies of the product and stuff like that. So it's always good to get an outsider perspective as well, I think.
Amen. And so with that, we have no more questions. So I do thank you, Warner.
Thank you guys for having me. Thanks everybody for staying the whole hour and taking the hour from your day to join us today. Really appreciate it.
Yeah, thank you so much. And we'll talk to you next week when we'll have yet another presentation.
Have a good day, everybody.
Much,
Thanks, everyone.
Bye.
Bye.
Bye.